Hello everyone. In this video, we will discuss about uniform velocity and variable velocity. So we know velocity and displacement, these are vector quantities. And for the vector quantities, magnitude and direction, both are very important. Or we will mention both magnitude and direction. Earlier we have discussed about uniform motion. Uniform motion means object has traveled equal distance in an equal interval of time. That motion is uniform motion, and whenever there is unequal displacement for the equal time interval, that motion is non-uniform motion. So first we will discuss about uniform velocity. So we know uniform velocity means body travels equal displacement in equal interval of time. Remember here we have mentioned the displacement because velocity and displacement are vector quantities where we need to mention direction also with the magnitude. Right. So uniform velocity means the object is traveled equal displacement in equal interval of time. So graphically, if you want to study, if I plot displacement versus time graph, and if you take four time intervals which are shown in green color here, so 1, 2, 3, 4, the time interval is shown in green color, and the corresponding change in displacement for that particular time interval is shown in red color. So this is for time interval 1, this is for time interval 2, this is for time interval 3, this is for time interval 4. So if you observe in this graph, the change in the displacement for the corresponding time interval, you take any time interval 1, 2, 3, 4. For all the time intervals, change in displacement or the height of this red color line is same. It's same for every interval. So if I take the ratio of ds divided by dt, change in displacement divided by change in time, here that ratio will be constant or it will be the same for any time interval. Here, now after connecting those points, the point here, if I connect the line and if I draw the graph, that graph will pass through the origin. So this kind of motion is uniform motion, and the corresponding velocity, we will call it as a uniform velocity. About the non-uniform motion, we know here the change in displacement with respect to time is like change in displacement and corresponding time. If a ratio of that, if you take, it is constant. But here in non-uniform motion, ds1 divided by dt, ds1 divided by dt, that ratio is, or ds divided by dt ratio, if I take, that ratio is different for different time intervals. Here the height of ds1, height of ds2, height of ds3, height of ds4, every year, everywhere, for every time interval, it is different. And ds4 has the highest magnitude, ds1 has the lowest magnitude, and from ds1, it is in an increasing manner or it is in an increasing order till it is reached to ds4. So this kind of motion is non-uniform motion. Here the graph is linear, here the graph is curved, or this kind of motion is non-linear motion, or we will say it as a non-uniform motion. Here the change in displacement, it is increasing, but for this graph the change in displacement is decreasing. So here we will say it is a decreasing non-uniform motion. So uniform velocity, when we will say, when the body or object travels equal displacement in equal interval of time. And about the variable velocity, when the body is traveling unequal displacement, like here the unequal displacement for time interval is the same. It is here, it is covering unequal displacement in equal interval of time, but here body travels equal displacement in equal interval of time. So this motion or this velocity we will say as a uniform velocity, and these velocities are the variable velocities. For the uniform velocity, the body travels equal displacement in equal interval of time, and for the variable velocity, body travels unequal displacement in equal intervals of time. Thank you.